Hello and welcome to today's class. Let's dive into the second part, or perhaps the second kind of multiplication of vector that we have. When it comes to multiplication of vector, in our previous class we said there are two types of vector, right? In terms of multiplication, we have the dot product of vector and we have the cross product of vector. I've done a video to explain the first multiplication of vector called the dot product of vector, right? So let's now dive into the cross product of vector, also called vector, right? So either the first one is called scalar or dot product of vector, second one is called vector or cross product of vector. So let's look at the concept of cross product of vector. So let's say given a vector a to be equal to axi plus ayj plus azk, given a vector a as this and given a vector b as bxi plus byj plus bzk. Their cross product of these two vectors is written as a cross b. So when it comes to cross product, the symbol for representing cross product is what? Is a times. For dot product of vector, if I have vector a dot vector b, this is what? This is a what? A dot product of vector, a dot. This is a what? A cross product of vector. So given two vector a and b, their cross product is written as what? As this form, right? So what would not be the formula for calculating cross product of vector? So let's derive the formula. By the way, when we did scalar vector, I derived the formulas for you. So similarly here, let's derive the formula when it comes to calculating for the cross product of vector. So first, my first task here is that I'll try my let's start from here. I'll draw a circle this way. We are trying to prove the formula that a vector a cross vector b will be. So I'll have, observe please, I'll have I, j, and here with k. So start with this please, I, j, k. So start with I, j, k. All right. I want to try to prove this formula for you, right? So let's start. This is what we start with. This is I, j, and k. This is k. All right. How do you prove this? First, if I start proving something, you have to know some stuff. Like what? Now, look at the concept. I'm going to move in a clockwise direction first. Moving in clockwise, I expect positive answer, right? Start with this, please. Start with I, because I must come before j before k in a mathematical sense. So this becomes I first. Start with I. So I, right? I cross what? J, we give what? K. As easy as that. Start with I cross j, we give k. Now what's next there? Move to j. So j cross what? K, we give what? We give I, right? What's next there? K, Abi. So k cross product what? I, we give what? J. I'm done with clockwise, if you observe. Now move to what? Anti-clockwise in this form, right? So I expect a negative answer. Start with what? I, k, right? So I cross what? K, we give what? But what? A minus what? J, because it's a negative direction. I'm done with I. Pick k. K cross what? J, we give what there? Negative I. What next? I pick k. What next? J. So j cross I, we give what there? Negative k. So these are like the stuff we need to note when it comes to deriving the formula for the cross product of two vectors. Hold on, note this please. Under this, note this please. Note that I cross I will give 0, j cross j will give 0, and what? K cross k will give 0. In when it comes to a dot product of vector, if I have a dot a, if I have for the first one that we did, that was dot product of vector. If I have k dot sorry, I dot I, this is equal to 1. K dot K, this is 1. And what there? What next? J dot J is equal to 1. But in this case, it's different because what there? 0. So this one is for what? Cross product. This one is what? Dot product. This is cross product. This is dot product of vector. So we don't need this, right, for now. So let's proceed, please. Let's proceed. All right. So from here now, here's the tax. So look up from here. I'll go back to this. So we're trying to put formula. So if I have two vector A multiplying vector B in terms of cross products, what will I have? Look up. Please, what's vector A alone? What I have vector A is there? Is what? A x I plus A y j plus what? A z k. That's vector what? For vector A, Abi. Cross vector what now? B. What's vector B? B x I plus B y j plus what? B z k. So I have these two vectors, right? All right, let's proceed with this. Now here's the thing, that's very easy. I'll try to multiply each of them, right? Look up, hold on, stop writing this, hold on. This is now equal to, if I multiply these two vectors, all I have as my answer, look up, start with A, since AXI, I'll use AXI alone to multiply what? Everything. Okay. Similarly, I'll use AYJ to multiply what? Everything. And finally, I'll use what? AZK to multiply what? The everything. So here's it. Start with this, please. Start with AXI. AXI and everything there becomes AXI. Hold on. AXIB times what? BX, right? Times BX into, here was I, Abi. Here is now I too, Abi. So you bring that vector like separately. Those I separately, JJ and KK separately. You now combine what I'm having AX here, BX. These are the two here. This is I together in the brackets. I'm done. I'll use this one to expand this. So use this one again to expand this one. So plus what's here? AX Abi. This is what? BY into, here was what? I. Here is what? J. So I have it, please. This I have it. Let me just write the J very well so that it will not confuse us. All right. What next there? This same one, what? This last one, Abi. Yeah. So plus AX BZ. What next there? I what? I K. So I have this. We are done with what? This first one, Abi. Move to this one, please. Plus this is what? AY and what the BX first? BX into what? JI. So I have JI. I'm done. This with what? This, right? Plus AY BY into what there? J, right? And what? J. I have this. What next? This one with what? Last one, Abi. So plus AY BZ into what? J dot what? K, Abi. JK, true? Yes, JK. This with this now, right? So this is J and K. So what last one there? AZK with everything, Abi. So plus AZ with first one, yes, what? BX. What's yes, what? K, Abi. K and what? And I. Sorry. K and I plus this one with next one, Abi. That becomes AZ BY into K and J plus what's next there? This with the last one, Abi. Yes. That's AZ BZ K and K. So I have K and K. Hold on. At this point now, we said that JJ, if I see I together, it's 0, Abi. JJ together is 0, Abi. So observe that here becomes, this one gives me 0. True? Yes, of course. JJ, yeah. Abi, this should give me what? 0. What again? KK. This one here should give me 0. True? All right. What's left now? If I multiply vector A with B in terms of cross product, what will I have there? That's what? AX BY into what? IJ plus AX B what? BZ into what? IK plus AY, observe, is AY BX into what there? JI, yeah, plus what's next there? AY, this man, BZ into what? JK, true? Well, here now. So remain this and this. So plus A what? AZ BX into what? KI, right? Plus AZ BY into what there? KJ. Alright, almost done. If I multiply these two, vector A with vector B in terms of cross products, all I have. Hold on, no, look up. Let me check IJ. What's IJ here? I must start and J. IJ. Hold on, no. IJ. That's what? K. So for me, I will have that. I will have AX BY into what? K. I'm done. I'm done with this. True? Move to this, please. Plus, this is what? AX BZ. I have IK. Check. IK. That's what? Minus J. Minus J. Alright. Plus, right? I'll pick this and this. What next? This one will be, that's AY, right? BX into what? What's JI? JI. That's what? A negative K. Minus K. Alright, what next? We'll pick this, right? Let's pick this one. Plus AY BZ into what's JK? Of course, JK. JK is what? I. So I have I'll pick this man. What next there? This one here. Plus AZ B what? BX into, please, KI. KI, that's J. So I have J here. Plus pick this one, Abby. Final one. That becomes what there? AZ BY into, please, KJ negative I minus what? I. Alright, I have this one here. So tax is that I will try to collect like terms here. I can see J, I can see K, and I can see K. Right? So they're family. I can see J, I can see J here. Family. I can see I can see I. Family. So I'll rather start by what? Collecting like terms, right? But in this case, I'll start as called that. I before K before J. So here's the concept. If I multiply vector A with vector B in terms of cross product, I will have what? This is start with I first because I should start as called that. I before K before J. So what's I? This I Abi. This I Abi. What's I again? This AY. This I again Abi. These two have I. But this is a positive Abi. Start with the positive of what? Negative. Right? So I'll be having what? What is one first? This A what? AY BZ, right? Then what? I. What next one? This one Abi. I have picked this. This one now is what? Plus what? AZ BY into what? Minus I. I have picked this two. So this I first. Before what? K. No, before J. So what's J now? I can see J where? J is here. J is here. Start a positive one first. This J is a positive J. That becomes plus what? AZ BX into J I have picked this man. This one next, Abi. Plus what? Ax bz into what? Negative j. What next there? I have picked j. True? Yes. What's left? Of course. K. These two. So I pick start. This is a positive k. Start positive k plus what? Ax by into k. Is that all? Which one, right? Plus a what there? Ay bx into what? Negative k. So I have picked these two. So almost everything picked already. So these are really like terms, right? Now here's the thing. Look up. Look up. Look up. Look up. Look up. This one will remain the same. Abi, look up. If minus times plus, all I have minus. Abi. So in essence now, my formula for the cross product vector, if I multiply from there, continuation please. If I multiply vector A with vector B in terms of cross product, I will have what? Look up, look up, look up, look up. Look up, here's the thing. Observe that I is common, Abi. But here's the thing. Minus times plus what? Minus. So I should expect, observe that I say that I is common, Abi. Into what? AY. What's AY? AY, BZ, right? No, hold on. This I and I is common, Abi. Bring it out. Yeah. Now this minus times plus what? Minus. So I what there? A minus what? Minus what? AZ BY. Normal math. This times this will give you that thing that is there. This times this will give you this. Next up, I times minus this will give you minus I this. So I'm done with this first part. Move to J. The same thing applies to J. What do you observe? This one with times plus, Abi. Yes. So I should expect, so plus, observe. I have picked everything here to this place. That's it here, Abi. What's next now? J family, Abi. But I'm seeing a plus first. So I put plus. Plus. For J family, observe that I can see negative here, Abi. Yes. Minus times plus what? Minus. And I know that J is common in between. So bring out J first. Bring out J outside into what? What's for J? That's AZ BX. So what? Minus. Yes, minus. What? AX BZ. I have this. Right? So plus. All the final one there. KKB. That because what the K into what? AX BY minus, exactly, minus what there? AY BX minus AY, perhaps AY BX, AY BX. So now, so this becomes the formula for calculating the cross product of two vectors. So this is your formula for calculating the cross product of two vectors. By the way, if you observe that this formula is quite much complex, even easy to remember in exam, it's somehow hard and difficult to remember in the exam. So I'll give you a shortcut. We'll be using determinant concept, right? 3 by 3 determinant. So just write this one down and then we'll proceed to the shortcut, because I can't even I can't advise you to start using this in exam. It won't be easy to remember this formula, right? And you miss it up. So I'll give you a shortcut using the determinant concept. But by the way, I still have to show you this concept so you know that it exists. So I should have got to give you a shortcut, but though you should know how this one too exists. You should know how it works. So I'll give you a shortcut now, as very shortly. So and that will be shortcuts in solving problems. All right. Let's look at determinant of cross product of two vectors. Then I'll show you the shortcut. So I'll go to this procedure. All right, let's improvise. Instead of using this long, perhaps long formula to start solving cross products, let's see how we can possibly evaluate, or perhaps using the shortcut let's see what the shortcut concept is all about. So by the way, the shortcut concept is all about using the concept of determinant of 3 by 3 matrix, right? I've done the video, a mathematics video, that explains 3 by 3 determinant of a matrix. So that's what we're using here basically. So let's say I have two vector, as we did here. These two vector, we have these two vector, right? And I'm told to find the cross product. It's easy. How does it work? So it's here the concept. The cross product of two vector A and vector B will be equal to, observe what I just did now. I'll have a line this way, whereby I have I, J, K in everything. So I start with I, J, hold on. Start with what? I, J, and what? And K, this way, right? Next up, observe your I. Sorry, just this way. Now observe your I. For I have what? AX, Abi. Under I have I here. So I have AX. Look up. I have AX. Yeah, I have what? BX. That's for I. For J, I have what? AY. BY. For K, I have what? AZ. BZ. I have it here. So this is how it works. So if I give a question in this form, just try your best to what? Take it down this way. Just I, J, K. And your I are this and this, J are this and this, and K are this. This is called a 3 by 3 determinant of a matrix. So we apply the math concept here. So what's the math concept? Your very first task is to introduce a sign. What do I mean? Start with plus, minus, plus. That's the rule. If you don't know your normal mathematics, this is the concept I'm applying here. So start with what? This is plus J, I, Abby. Yeah. So start with plus I first. So for plus I, observe, sorry, this is J. Plus I. For I, observe, please. Oh, here's the concept. Here's the concept. If I start with plus I, I'm going to cover the row and column of I. This is my row of I. This is my column, Abby. Yeah. If I cover it up, cover these two up, I'll be having AY, AZ, BX, BY, and BZ left. Cover the row and cover the column, like this row and column. I'll be having this 4 left, Abby. So I'll have AY, AZ, the sound of entering my mic. The sound of entering my mic. Ringing stop. Perhaps. Alright, proceed please. So we said for I, start with plus I, right? For this your I, I'm going to cover the row and column of I. So I'll be having this one and this left. So I'll have BY, and BZ. So that's for plus I. What's next there? I'm having J, minus J. So I have it minus J. For minus J, what do you see minus J? We said for every part you are picking, cover the row and the column, right? So for J, this is my column of J. And if I cover the row, I'll cover this part here. I'll be seeing 1, 2, 3, 4 left. Observe. 1, 2, 3, 4. So I'll be having AX. I'll be having AX, BX, and what? AZ, BZ. That's for J. What's next there? For K, plus K. So for plus K, what I have there, I'll cover it for K, the row and the column. So I'll have just these 4 left. AX, AY, BX, BY. So I'll have AX, AY, BX, BY. That is for what's it called? That's how this is how you work on this first part. First, introduce your sign. When you are done, pick each of them and then cover the row and column and write out what you are left with. So I'm here. Next up, observe that this ones here are 2 by 2 determinants. So I'm going to evaluate them using 2 by 2 determinants. If you don't understand matrix and determinants very well, you can't get this concept well. So I'll drop a link to the mathematics video that will help you understand the concept of determinants so you can flow with this. From here now, I'll have plus I, that's plus I, open a bracket this way. So to solve or to my camera. All right. By the way, this is a 2 by 2 determinant, Abi. To solve this one, it's easy. Multiply the diagonal, what's it called? Multiply the diagonal line, perhaps. Let me call it, okay, here's the thing. Here's my right hand side, here's my left hand side, right? So I'm going to multiply this right hand side first. This AY and BZ together. So multiply AY and BZ. AY times BZ, I will have AY BZ, right? Minus, multiply the left hand side together, AZ BY. So I have AZ BY. I'm done with this first one. Come down here, negative J minus J into what? Multiply this right hand side together. So AX BY. So AX B what? Sorry, BZ. AX BZ minus these two, that becomes AZ BX. I have this. Next up, plus K into this and this. AX BY minus AY BX. So I have this. So this is your formula for calculating the cross product of two vectors. We have vector A multiplying vector B. In terms of cross product, I'll have this formula. So this is very easy and faster to get. Observe that my final answer and this one are still the same thing, right? They're still the same thing. So this and this one are still the same thing. So let's just follow the shortcut procedure. So this is how you derive formulas for cross product of vector. All right, let's take few examples. Okay, hold on. Before I move to example, let me show you how to calculate if you have to calculate for angle in terms of cross product. So let's look at angle in terms of angle. In terms of angle, in terms of angle, the cross product of two vectors, let's say vector A and vector B, is given as determinant of A and determinant of B sine theta. If I'm told to find the angle in between two vectors such that they are being what is a concept under cross product, the concept is simple. I'll have the cross product of two vectors and then determinant of this vector A and B sine theta. In this case here, let's make theta subject. If I have to make theta subject, I have to make sine theta first subject, Abi. I'll divide both sides by what? By this one. So divide by the magnitude of vector A and vector B. Divide by magnitude of what? Vector A and vector B, this way. So this one cancel this. I'll have sine theta left. Sine theta is equal to these two, the cross product of vector A and B, all over magnitude of A and what? Magnitude of B. So I want to make theta stand alone. So it's easy. I'll take sine over here, becomes a sine inverse. Take sine over here, becomes a sine inverse. All right, look up from here. Take sine here. I'll have sine. This theta. Theta now is equal to sine inverse of what? Of the cross product of vector A and B all over the magnitude of vector A and vector B. By the way, I've taught you guys how to calculate for magnitude of vectors, right? In our previous class before now. So you should know how to do that. Alright, so let's calculate for angle. We are trying to find the angle between two cross product of vectors. This formula you apply. So this is how this works. Let's take example. and explain this concept better. Hold on guys a little bit. Let me tell you what you need to know. Actually, I'm running a membership program, right, which can help you a lot. So to join my channel membership, it's quite easy task, right? As you can see the icon I'm showing you here, that icon is my membership opportunities, which you can access monthly. So I'll drop the link to the membership in the description of this video, right? So just click there, click on the membership link, so you purchase the one you want. So I have for JAM and YA classes, and also I have for 100 level students. So whichever one suits you, click there and subscribe. If you perhaps click there and purchase the one of your choice. Anyone you purchase, there are several advantage videos that I will not allow people to see. So it's for only those who have joined the channel that will have access to those even advanced problems. And also I do help students from different countries to solve their assignments. So if you're in UK or abroad or Canada or anywhere you are in the world and you want me to help you do your assignments, you can simply you can simply visit me on my WhatsApp number, or also share this video. I'll drop a link to a website there. In the website, you can register with us and you let us know which assignment you want us to help you to do. Do well to join the channel. Thank you. You can proceed with your learning now. Example. Let's say I'm given two vector. Vector A should be equal to 2i plus 3j plus 4k, and I'm given another vector B, to be equal to I minus 2j plus 5k. Alright, find vector, the cross product of vector A and B, and also the angle between the two vectors. All right, let's solve this problem. Let's solve this problem together. All right, how do you solve this? It's easy. I want to apply our shortcuts that we just learned earlier, which is using the determinant concept. All right, from there I have two vectors A and B. As you can see, my very first task now is that we are going to find what first? The cross product of the two vectors. So solution, the cross product of the two vectors, vector A and B, is equal to what? Draw a line this way. Now I'm having I, J, K, so I'll have I, J, and what? And K. For your I, my I here is 2, Abby. Yes. I here is what? Invisible 1 is here. Yes. So I have 2 and 1. Here becomes 2. Here becomes 1. For J, check your J. Is plus 3, Abby. Yes. It's same as 3. Here is minus 2. So I have 3 and minus 2. Here is 3. Here is minus 2. For K, I have 4 and 5. As you can see, 4 and 5 for K. So I have 4 and 5 for K. So I have this. From here, what next, please? We said it's easy. We said introduce your sign. Plus, minus, plus. Start with plus I. So I have plus I this way. So if I have plus I, I'll call the row and column, like the row and column of I. I'll have what here? I'll have this one, letter B. That's what? 3, 4, minus 2 and 5. That's plus I. What's next now? Minus J. Minus J. For minus J, if I cover this place and this, I'll have 2, 4, 1, 5 left. So that's 2, 4, 1, 5. That's for J. Finally, plus K. For K, all I have there, cover this row and column. I have 2, 3. 1 and minus 2. 1 and what? Minus 2. Are we done? Yeah. Not yet. What next there? From here, I'll have plus I. Open a bracket this way. Look up. 3 times 5 is what? 3 times 5. 15. That becomes 15. Minus 4 times minus 2 is what? Minus 8. Minus 8. Observe the way I did this now. Observe. Right? Yes. Minus. This is minus Abi. Yes. J 10. Into multiply this 2. 10 minus multiply this 2. 4. I'm done. K. Plus K into 4. Multiply this 2 minus 4 multiply this 2 minus what? 3. That's the concept. Let's get this done. Yeah. If I'm to proceed from here, what should I get? Alright, I'll have plus I. Open a bracket. Look up, please. Minus is what? Plus IB. 15 plus 8 is what? 25. 20. Or 26. 6, right? 26. Right? 15, 16, 17, 18, 19, 20, 21, 22, 23. Per se. 23. Alright. Next up, minus J into, what's my answer here? 6. Right? Plus K into what? Minus 7. True? It means that if I'm to, the cross product of vector A and vector B will be equal to what? 23I minus 6J minus 7 what? K. Observe now. 23 times I. 23I. 6J times 6 minus. This is 6J. Minus plus what? Minus. Sometimes K is what? 7K. I have finally got the cross product of these two vectors. That's your answer. Now let's say that what again? Also find the angle between them. It's easy. So calculate for angle. Calculating for angle. That's theta. What do we know? Theta equal to what? The sine inverse of what? The cross product of the two vectors A and B all over the magnitude of vector A and what? Of vector B, as you can see, and that's all. We have gotten this one, Abi. This is the value here. Let's now get magnitude of A and B. So finding magnitude of A first. Let's start with A. Let's find magnitude of A first. Okay. For magnitude of A, that's magnitude of A is equal to what? The square root of, what's your A? So I'll pick 2, 3, 4. All right. That becomes 2 square plus what? 3 square plus what? 4 square. So I will ignore those IJK. I'll pick them in front of them and square them. That's how to find the magnitude of a vector. So that's it. From here, if I proceed from here, I've done the videos to know the stuff. So just try to watch them, revise them so that I can understand this concept of cross product. Alright, proceeding from here, the magnitude of vector A should be equal to the square root of 4 plus 9 plus 16. So what I have here, square root of 4 plus that's 29. So this answer is what? Root 29. So the magnitude, of vector A is what? Root 29. Let's also find root magnitude of B. Right? Yeah, that's the concept now. I've gotten for A. Next up is B. For B, the magnitude of B will be equal to what? Square root of, pick out the coefficient of those terms. What's here? 1 here. Abby?
Yes.
That becomes 1 square
minus 2 square
minus what? No, everything is plus. So plus into what? Minus 2 square. Observe the writing. What next there? Plus 5 what? 5 square. I have this. This is now equal to, what's 1 square? Of course 1. That's 4 plus what? 25. This will give what? Root 30. 4 plus 1 is 5, Abby. 5 plus 25 is 30. So my magnitude of vector B is what? 30. Alright, let's now get the angle easily. So the angle now, so look up. The angle as I have here now will be equal to theta now is equal to sine inverse of what's vector A and B? That's 23. That's what? 23 what? I minus what? 6j minus what? 7k. All over what's magnitude of A? Root what? Root 29. What next there? Times what? Root what? Root 30, right? Abby? Now here's the thing. We said the concept is that we're going to look for the magnitude of this cross product 2, right? Look for the magnitude 2. So let's get the magnitude of this cross product. We have got the magnitude of A and B, and when our cross product is this value, right? So there's no how I can simplify this, right? So I'll have to find the what? The magnitude of this one itself again, of these two vector. Copy this down first. All right, so here's the concept. At this point now, I've gotten magnitude of A and B. Let's also get the magnitude of this one, because the answer was this, right? So I should have go ahead and get the magnitude of this vector. But hold on, let's get it here. The magnitude of vector A B will be what? What is one B? The square root of what? That's what? 23 square plus what? Minus 6 square plus what? Minus 7 or what there? All squared. I'll get a magnitude for each of them. For this one, the answer was this, right? Get a magnitude 2. All I have here, this calculator, is equal to the square root of, if I'm putting on calculator, for me I should have, yes, 529 plus 36 plus 49. From me I'll have root 614 as my answer, right? So therefore the magnitude of the cross product of the vector A and B will be equal to, what's root 614? That's about 24.78. So this is my answer. Perhaps I can choose to get the values in decimal. So we're done now. From here, I will not put this value inside here instead of using this one. So I'll put this value in place of this one here, and that's all. All right. From there, the angle will be equal to sine inverse of what now? What's the magnitude of A and B? The magnitude of A and B is what? Okay, 4.78. That's 4.78 all over root what? Root 29 times what? Root what? 30. Theta is equal to, if I press sine inverse of, if I divide everything here, I should have sine inverse of 0.884. If I divide everything here, I'll have this value. So if I put calculator, if I press sine inverse of this value, theta is equal to 57.14 degrees. This is how calculate for the angle. By the way, always get the magnitude. Let me just put this, let me check this inside. So get the magnitude of the cross product of vector and also each of them in this this form. So this is calculate for the vector, the cross product of vector of two vectors and the angle between them. All right. Also note that if two vectors are parallel, it means that their cross product is equal to 0. So when two vectors are parallel, that is, they cannot meet. When we say parallel, when two lines are going this way, so the angle form here is nothing, is 0. So it means that when two vectors are parallel, it means that the angle there is what? The angle there is 0. So it means 0 means that their cross product also will be 0. So note that, very important. All right, this is all concept behind cross product of vector. All right, see you in the next class. This one should take like hours because I don't know why it's too long. It's long, seriously. Imagine 50.